For question 12, we need to know the probability the total score is a 10. So we need to know all the places where you get 10. So the different possibilities is the first thing I'm going to write down. If I get a 4 on the blue spinner, I can get a 4, 2, 6 or 8 on the second spinner. If I get a 6 on the first spinner, I can get a 4, 6, 2 or 8 and so on. So if I get 8, I've got 4, 2, 6, 8. And if I get 2 on the first spinner, I've got 4, 2, 6, 8. Now only a few of these make 10. The first one that makes 10 is if I get a 4 on the blue spinner and a 6 on the red. If I get a 6 on the blue spinner and a 4 on the red, 8 and 2 and 2 and 8. So there are only 4 possibilities where I'll get a total of 10, but there are 4, 12, 8, 12, 16 different totals altogether. 4 out of 16 is fine, so is a quarter. Part B, we're using what we worked out in part A to help us a bit. So I'm not going to redo the diagram, but we were talking about an estimate of the number of rounds. So what we need is the probability that Ali will win multiplied by the number of games. So we basically need to know what's the probability that Ali will win. And Ali wins when the blue spinner score is greater than the red spinner score. So what I'm going to do on my diagram, I'm going to use a different colour just to make it really clear, is I'm going to show you where the blue spinner is greater than the red. So here, 4, 4, they match, so that's no good. 4, 2, yeah, blue's greater. 4, 6, 4, 8, no good, because the blue is less than the red score. If the blue score is 6, and the red is 4, that one's useful. 6, 6, no good. 6, 2 is good. 6, 8 is no good because the red is higher. When blue is 8, all these 3 are okay, but obviously 8, 8 is no good. And if the blue score is 2, then none of these are any good because the red score is higher or equal each time. So there are 1, 2, 3, 4, 5, 6 different occasions when the blue score is higher than the red score, and there are 16 different possibilities still. So 6 out of 16 times is when Ali will win. They're going to play 80 rounds. They're going to times by 80. You can just work that out, or you can say that out of 16 games, 6 of them Ali will win, and you can try and get this 16 to be out of 80. So you can either, if it's a calculator paper, I would just type that in a calculator. You can do it by doing 480 divided by 16. Cancel it down. So I'm going to divide by 2. So that's 240 out of 8. And I know that 24 divided by 8 is 3. So 240 divided by 8 is 30. The other way you can do it, like I said, is 6 out of 16 is 12 out of 32, which is 24 out of 64. And if I add this on again, that's 30 out of 80. Or you could have gone from here and times by 5. And you get the same number of games that Ali's going to win. So altogether, make sure you write your answer clearly. She's going to win 30 games. Algeria is 34 million, so 34 million is 3 4 and then 6 zeros. I'll put that in standard form. I'm going to use 3.4 because the number at the front has to be less than 10. All I need to know is how many jumps. So 1, 2, 3, 4, 5, 6, 7 jumps. So that's 3.4 times 10 to the 7. Part B, we've got the land area of Algeria is this, and 5% of the area is used to grow crops. Work out the area that's used to grow crops, so I need to do 5% of 2.4 times 10 to the power of 12, which if I write that out, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, worth a quick check. 10% will be 2, 4 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros because one of them will be crossed off. So 5% will be half of that. You can of course do this in standard form, I just think sometimes it's easier to think in the numbers. So it says write your answer in standard form, so you need to make it look like that. But here's the tricky bit, in kilometres squared, because this is metres squared. Now if you think of a box, 1 kilometre squared would look like that. But 1 metre squared would be 1,000 metres. Sorry, 1 kilometre in metres would be 1,000 metres. So 1 kilometre squared in metres is going to be 1, so 1 times 1 is 1, but with 6 zeros. So it's 1,000,000 metres squared in 1 kilometre squared. So if I want to know how many kilometres squared this is, I've got to divide by 1,000,000, or cross off 6 zeros. So I'm left with 1, 2, 3, 4 zeros, kilometres squared. So that's 120,000 kilometres squared, which is 1.2 times 10 to the power of 1, 2, 3, 4, 5 kilometres squared. Question 14, we've got to work out the fraction that's shaded. You've got 2 triangles and a rectangle, so I'm going to work out the areas of the triangles, the area of the rectangle, and take them away. The problem is you've got no numbers. Now you can do it in algebra, but I think it's a bit harder. What I like to do is assign a number to the sides and use that from there. So we're going to call the width 4, or the height 4, and the length 10. X is the midpoint, so I know that this distance is 5 and this distance is 5. Z is the midpoint, so it's 5 and 5. And Y is the midpoint, so it's 2 and 2. So the rectangle would be 10 times 4, which is 40 centimetres squared. This triangle is 4 by 5. So 4 times 5 is 20, but because it's a triangle, I've got to half it, so that's 10 centimetres squared. The other triangle is 5 by 2, that's 10, but I've got to half it because it's a triangle. I want the shaded area, so I've got to take the 2 triangles away from the rectangle. So shaded is 40, take away 10, take away 5, which is 25 centimetres squared. Oh, we're saying centimetres squared, but it's just units squared really, because we don't know it's centimetres. So for the fraction, it's 25 out of 40, which is fine. It's a nice clear answer. You can simplify it if you want to 5/8.